Hi, and welcome to my Weather IoT node project. This board is basically is meant to gather weather data and aggregate it over the network, and basically stream all the data to a dashboard that uh, encompasses a user interface that people can use to control. So we'll quickly go over what this board does. It's got a SPI flash chip that is used to store over-the-air firmware upgrades. The firmware is downloaded into this SPI flash chip, and then upgrade the software on the Wi-Fi enabled microcontroller. It's got two buttons here. One's for resetting the target, and one's for whatever user functionality is needed. This is the entire power staging area, which basically converts the voltage from the battery to a 3.3 tolerant voltage for the microcontroller. It's got two sensors. This is a aggregate of temperature and humidity, and this is an ambient light sensor. So essentially, all three sensors gather local ambient weather information and cast it to the dashboard. So now we're going to go over some dashboard functionality of the device. So here's the little dashboard that I've built. It basically plots the temperature over time. You can see there's some spiky and jitter in the temperature information that's being sent out. Although this data is filtered by a 10-point moving average filter. The humidity is a lot more stable. This is filtered by the exact same filter that the temperature is filtered by. So not quite sure what's going on there, but it displays the firmware version that's running on the board right now, and it also gives you the sensor health. There's sort of a sensor watchdog that runs on the software that measures how often the sensor has responded successfully, and if the number of times the sensor responds unsuccessfully exceeds the number of times that it responds successfully, this display here is going to change to attention. It's also displaying a heartbeat that basically has a timestamp in GMT time format, which is for 4 hours ahead of EST Center Time. You can use these buttons to basically query the version, upgrade the software, and turn the LED on and off. So now we're probably just going to demonstrate some of the functionality of the board. I'm going to go ahead and turn the LED on and off so that you guys can see what's going on with the board over here. So there we go, the LED is on and the LED is off. So now I'm going to demonstrate the firmware upgrade. It's going to take a little bit of time. So there we go. It's in the process of downloading the firmware. You can see the humidity has stopped changing. The timestamps have stopped coming in. It's going to take a little bit of time before it comes back up again. There we go, it's back on. Firmware upgrade is done. Now to validate that, we're just gonna basically query the firmware version. So there we go. The firmware version's 2.0, and it upgraded from 1.0. The sensors are doing okay. You can see the temporary dropout over here, which is basically because the software was being upgraded on the target microcontroller. Here's the humidity. It's being primed right now. It's getting filtered, so there's some amount of jitter. Same goes with the temperature. The filter is a 10-point averaging filter. So the 10 points in the window have to actually fill up before the temperature starts to stabilize. So yeah, that's it. That's pretty much it for the demo. Oh yeah, and just before we call it good, these pins are used for the UART to debug the onboard target microcontroller, basically send and receive data to make sure the board's mostly used for software development. All right, thanks for watching, guys, and goodbye.